So let's look at some patterns, see if we can figure out something so that we can have an idea of how many zeros we're working with. If you look at this one, first of all, what kind of a polynomial is this? Third degree. Third degree has another name. What's the other name? Cubic. So we have a cubic or third degree polynomial. And it had how many zeros or x-intercepts? 3. Okay, this is one that we explored in that polynomial function exploration. Okay, so we're just summarizing all the stuff that we've done. So we had 3 zeros or 3 x-intercepts. So this was a cubic or a third degree, and it had 3 zeros. Okay, what about the next one? What's that? What kind of a polynomial is this? A quartic. Quartic, also known as a fourth degree polynomial. How many zeros does it have? 4. Okay, how about the next one? Cubic. How many zeros does it have? 3. How about the next one? Cubic again. How many zeros? I would say 1. But what happens? Yeah, it happens more than once, right? So we have a 1 with a multiplicity of 3. We have 4 in there 3 times. Okay? So it's 1, but it happens more than once. 1 0 occurring 3 times over. Okay? Next one. Cubic. How many zeros? 2. And one of them has a multiplicity of 2. Okay, how about the last one? Cubic. And 2 zeros, or 2 x-intercepts, and one of them has a multiplicity of 2. So what are you going to predict about cubics and quartics and quadratics and other polynomials? Can you figure out how many zeros they're going to have? Based on what? Yeah. Whether it's a cubic or a quadratic or a quartic, its highest power, right? Its degree. Okay? Based on its degree, you know how many zeros it will have. Now, these happen to be all real zeros. Okay? These were ones that crossed through the x-axis in some place. There are some others out there that are imaginary, complex ones. They're not going to cross the x-axis where we would predict them that they will. Okay? Because they're not real. They're somewhere out there. So it'll do some loop-de-loops higher or loop-de-loops lower, but it won't actually do them. It won't dance along the x-axis all the time. Does that make sense? The zeros impact where those graphs are going to look, or what they're going to look like, how they're going to behave. Okay, so the rational root theorem says that for every polynomial with integer coefficients, okay, whole number coefficients, okay, every rational solution of that function, every time we set it equal to 0, all the zeros will either be a factor of the constant and will be a factor of the constant over a factor of the leading coefficient. Yes. I would write this down. You bet. Okay. And you have some room kind of maybe in the bottom or what have you. Don't worry about the formal presentation. Just remember this. Try to not get into too much math speak here. But a factor of the constant over a factor of the leading coefficient is what those zeros have to be if they're going to be a rational zero. Remind me, what are rational numbers? Or better yet, we have lots and lots of rational numbers. Can someone give me an example of an irrational number? What's an irrational number? Math teachers get all silly about it around March 14th. Decimals, specifically decimals that don't stop, that don't repeat, that don't terminate, okay? Decimals like pi, right? Decimals like the square root of 2. Decimals like the square root of 3 or the square root of 5, okay? So if we have integer coefficients, then every rational solution to this equation is going to be, to this polynomial, is going to have factors of the constant over factors of the leading coefficient. So, as an example, if I had 2x cubed minus 7x squared plus 5x plus 3, that's a polynomial in standard form, right? So if we want factors of the constant, which one's the constant? 3, right? There's my constant. What's my leading coefficient? 2, the number that's being multiplied by the highest power. So, what are factors of 3? 1 and 3. Positive and negative 1. Positive and negative 3, though, right? Because negative 1 times negative 3 gets me positive 3. Okay, what are factors of 2? 1 and 2, positive and negative 1, positive and negative 2. So all of my possibilities for this one are 1, 3, 1/2, and 3/2. Those are all the possible roots, rational roots, that this particular equation can have. Made this one up off the top of my head. It may not even cross the x-axis. But if it's going to, it's either going to do it at positive 1 or negative 1, positive 3 or negative 3, positive 1/2 or negative 1/2, positive 3/2 or negative 3/2. If none of those are zeros, it's not going to cross the x-axis. So instead of an infinite number of things that we have to check, we've eliminated a whole bunch. We're down to 8 possibilities, and they can occur more than once. Make sense? Okay. All right, so on your notes sheet, I think, if I remember right, we have this example. Solve 5x cubed minus 40x squared plus 80x equals 0. It's number 6 on your sheet. So it's on the polynomial challenge side of your sheet, number 6. How are we going to solve something like that? What did we talk about the day before yesterday? What was one of the things we were doing? Yeah, what was the worksheet about yesterday, or the day before yesterday that I let you keep so that you could use it? Factoring strategies, okay? So we don't ever want to forget about our factoring strategies because factoring can be really quick. Do any of our factoring strategies work with this one potentially? GCF, okay? What do they have in common? 5x. So let's take that 5x out. We're going to try to find the greatest common factor. We'll take a 5x out of everybody. We can't just take it out of 1 or 2. We have to be fair to everybody. So when we take that 5x out, what's going to be left for the first term? X squared. What about the second one? I agree with 8x. What's my sign? Negative. So don't lose your sign. What's going to be the last term? 16. And what's the sign? Okay. We're halfway home. So what's next? We pulled our monomial out. We have a trinomial. What can we do with that? The opposite of FOIL, right? Okay, a t-chart, guess and check. So don't lose this 5x. We got to keep it out here. But we're going to get 2 sets of parentheses here. Don't lose your equals 0 because that's our whole point in this. We're trying to solve. What's going to go in the first parentheses? X minus 4. What's going to go in the second parentheses? Good. So 5x times x minus 4 times x minus 4. So what are my zeros? I agree, positive 4, because if I take x minus 4 and set that equal to 0, x is 4 twice, 4 with a multiplicity of 2. What's my other 0? Because there should be 3 of them. Right? Third degree polynomial, right? You told me it should have 3 zeros. What else will make that 0? You're almost there. Is 5 going to make it 0? 5 cubed times 5, 5 squared times negative 40, 5 times 80. Could be a big number. Very close. What will make this 0? What number should x be? If this is 0, if x is 4, this is 0. What makes this 0? Divide by 5, what are we going to get? 1x equals 0. Okay? So if x is 0, 0 times 5 minus 0 squared times 40 plus 0 times 80, we get a 0, don't we? So anytime you get to factor an x or an x squared or an x cubed out, then that can be a 0 as well. And that can make it equal to 0. Very cool with that? If I were sketching this, and you don't have to sketch a lot of these, I just want you to see the connections. Rising or falling on the right? Rising. Rising or falling on the left? Falling. Opposite powers, or odd power, falling, doing the opposite thing. Where is it crossing? The x-axis. At 4 and at 0. So we have a dot here, one here, and where's it going to kiss the graph? Thank you. At 4. It'll come down, it'll touch it, it'll bounce back up, and then it will go through. Okay. All right, next example. Find the zeros of this one from the polynomial challenge from yesterday. Number 7. Give you a couple moments to work it. All right, what'd you think? Factorable, right? We can factor this guy. What are the factors? Yep. We're going to have an x squared and a -9 and a -9. Did you notice right away, perfect square, a little different, more difficult than what we saw in Algebra 2 or Algebra 1, but perfect square here as well. So we immediately suspect it might be a perfect square times itself. So I like that. Okay, now what? Are we done? No. What do we have to do next? Do it again. Okay, so Jordan, what are we going to get when we factor x squared minus 9? Perfect. And I would assume that we'll do that again, get the same thing. So Laurel, what are my zeros? Good. And what do you think, Brenda? Good. Okay, very nice. So if we had to sketch this, what's it going to look like? You know this stuff, guys. What's it going to look like? Rising or falling on the right? Okay, rising or falling on the left? Why is it rising? Fourth power, it's even. Okay, so rising on both sides. And where are our zeros? Three and negative three. Gonna go do something here. And guess what? We have one more intercept that we haven't talked about. If x is 0 and x is 0, what's y going to be? 81. So it's going to be clear up here at 81, but it's going to cross the y-axis at 81. And what does that multiplicity of 2 make it do? Kiss the graph. So we're going to kiss that dot, go way up here to 81, kiss the dot, and go back up. Okay? The 81, good question. Because x is gone, x is gone, x is gone. We just didn't really think about it. It actually crossed at the origin when x is 0, y is 0. Yep, that will always be the y-intercept, way up or down low or wherever it happens to be. So that gets you one more point. X's are 0, that's your y-intercept. Okay. Number 8. Actually, number 9. Did I not put 8 on here? I must not have. We'll come back to it. Let's skip down to number 9. What's going to happen with this one? Cheyenne knows, she's just whispering it. Greatest common factor, pull the GCF out. So what's the greatest common factor here? 5x. X squared minus what? 10. Do we know how to factor x squared minus 10? Not quite, do we? It's okay. So what's going to make this first thing a 0? If 5x is 0, what's x? Yep. Okay. What would make the second parenthesis 0? Add 10 to both sides. I like that. We know how to solve that, right? From our quadratic days. So what would we do? Square root it. And we don't want to lose anybody. So what do we have to remember to do? Plus or minus. Do we know exactly what square root of 10 is as a number? No. It's somewhere between 9 and 16, so somewhere between 3 and 4 when we take the square root. Closer to 3 than 4. So you leave it like that. Okay. And if we graphed it, we'd graph somewhere between 3 and 4, and negative 3 and 4 as a point. Okay. See if I can add one more slide to this real quick, and we'll do that other problem. All right, number 8, x cubed. Come on, marker. plus x squared minus 14x minus 24 equals 0. Kobe, what are we going to do here? Four terms now, right? What does our strategy say? Factoring strategy says what? Anyone? Grouping. Okay. It may or may not work. Okay. In fact, I'm a little skeptical that it will, right? If I take an x squared out of the first two, I get an x minus 1. Will I get an x minus 1 if I take something out of there? No. I don't see a difference of cubes possibly here. Now we have to use what we was just talking about way back when, at the start. What are factors of 24? 6 and 4. What else? 3 and 8. What else? 12 and 2. And 24 and 1. It's a lot of possibilities. Good news is we've got a leading coefficient of 1, so everything is over plus or minus 1. So what should we do? When I asked you if something was a factor of something yesterday on your worksheet, what did you do? I want to know if x minus 1 is a factor of this, what would you do? Hoping the clock will save you. Everybody's looking at the clock. What did you do at the bottom of your worksheet yesterday? Or the day before? Why do I want to write this down? Good question. These are the possible ones, right? We could have earlier, but factoring's faster. So always try a factor if you can. Okay? But what is this? Synthetic division. And what do we know? What happens if we put in 1, for example? What are we looking for over here? A 0. So if we can't factor, okay, last resort is synthetic division. Okay? And then we work from there. So let's see if 1's going to work. How do we synthetically divide this? So 2, negative 12, negative 12, negative 36. Didn't work. What should we try next? We're close. Would have been nice if this was a positive 12, right? Something like that. So 1 didn't work. What should we try next? Lots of options, guys. 4. So if we try 4, 1, 4, 4, 16, 2, 8, didn't work. Okay, might need something bigger. Let's try 8. 9 times 8, 72. Oh, I'm going to get way too big too fast. Okay, let's try 3. Closer. Okay, let's try negative 4. Okay, 6. Oh, you said negative 1. I'm sorry. I thought you said negative 4. Let's try negative 1 and we'll try 6. Bless you. Okay, negative 1 didn't work. Let's try 6. 30, or 30. Oh, 7. Thank you. I'm trying to multiply. 42. 14 minus 42. Yep, and 6 times 28 is going to be way too big. Let's try 2. Can you see the futility here? Let's try negative 2. Maybe we need some alternating signs here. 1, negative 2, negative 1, positive 2, right? So negative 12, positive 24. Woohoo! Whenever we get a 0, we're going to put a big fat smiley face there. We finally got it. Okay? So negative 2 was one of our zeros. Good news is we now have a depressed equation. It was x to the third, right? We divided by an x minus x plus 2, so we took out an x. So what's this power now? It was x cubed, x squared, minus x minus 12. Can we factor that? What are factors of 12? 6 and 2, 4 and 3. Which one should be negative? I must have made a mistake on my 4. 4 should have worked. X equals 4 and x equals negative 3. So 4, negative 3, negative 2. Okay? So your assignment's the back of the sheet. And it's a self-correcting one, so it's a puzzle. You can tell whether you're getting the right answers or not because those answers should show up. Okay? Fortunately, not a lot of them that are needing to be done this way. G and H are the suspicious ones. G, H, and J.